The remainder and factor theorems. Let P of x be some polynomial and D of x be some linear divisor in the form D of x equals x minus alpha, where alpha is a constant. Then by the remainder theorem, the remainder of P of x divided by D of x is P of alpha. So just to show you how this works, if we express this division in dividend divisor quotient remainder form, so P of x equals D of x times Q of x plus R of x, rearranging the equation to make R of x or the remainder the subject of the formula, we have R of x is equal to P of x minus D of x times Q of x. Substituting in x equals alpha, so we have R of alpha equals P of alpha minus alpha in brackets times Q of alpha. So we can see that this whole term becomes 0, so therefore R of alpha equals P of alpha. Now if R of alpha equals 0, then D of x equals x minus alpha, so this linear polynomial here, x minus alpha, is a factor of P of x, so it divides it evenly. So more formally, if P of x is a polynomial, then x minus alpha is a factor of P of x if and only if P of alpha equals 0. Now as a note, or as a side note, P of alpha equals 0 means that alpha is a 0 of P of x and a root of the equation P of x equals 0. So that's the relationship between factors, roots and zeros. Now this is called the factor theorem, and you can see that it's related to the remainder theorem, or it's basically the remainder theorem where the remainder equals 0. In fact, if the remainder equals 0, then the divisor is a divisor of P of x. So for example, show that x minus 3 is a factor of P of x equals x cubed minus 2x squared plus x minus 12. And again, we can show this using the factor theorem without using long division. So we need to show that P of 3 equals 0. So P of 3, so substituting 3 into P of x, let's see what we get. So P of 3 is equal to 3 cubed minus 2 times 3 squared plus 3 minus 12, and we get P of 3 equals 0. Hence, x minus 3 is a divisor of P of x or a factor of P of x.